Hi students, today we are going to see a summation for the concept, right? Already we have completed two sums and one theorem. What is the name of the concept? By using the statement of Pythagoras theorem, right? By using the statement of Pythagoras theorem, we are going to find or we are going to prove whatever they are asking, right? So number 3, an airplane leaves an airport and flies due west at a speed of 2100 km per hour. At the same time, another airplane leaves the same place at airport and flies due south at a speed of 2000 km per hour. How far apart will be the two planes, not places, planes after 1 hour? See, this question is something but same like what is it? The application of trigonometry chart, right? Same like application of trigonometry, but with the help of Pythagoras theorem, right? Pythagoras theorem statement we are going to find, right? So first we want to know the directions, right? So north, south, east, and west, right? North, south, east, and west, right? So from an airport, right? From an airport, I'm just marking as O. O is something but airport, right? An airplane leaves an airport and flies due west, right? Due west. I'm just giving name. So OA is nothing but, right, distance traveled by the plane A, right? We are having two planes. Plane A, an airplane leaves an airport and flies due west at a speed of 2100 km per hour. At the same time, another airplane leaves the same plane at airport and flies due south, right? Moving due south. After 1 hour, the plane is something but in the place of point B, right? The plane is something but in the point of B, right? So now we want to find that after 1 hour, right? After 1 hour, how far apart will be the two planes after 1 hour? How far apart? So we want to find the distance between A and B. AB. We want to find the distance between A and B. So from the point O, right? From the point O, right? After 1 hour, the first plane travels how many kilometers? It is traveling. The speed of the first plane is nothing but 2100 km, right? So for 1 hour, it will cover 2100 kilometers, right? So OA is something but 2100 kilometer, right? OA is equal to, and OB is something but what is the speed? It is something but 2000 km per hour. So after 1 hour, how many kilometer it has been completed? 2000 kilometers. So distance between OB is nothing but 2000 kilometer. Now we want to find the distance between AB. How we want to find? See that OAB is nothing but right angle triangle, right angle at O, right? Right angle at O. Let A and B be the position of two planes after 1 hour. Distance OA is equal to 2100 kilometer. OB is equal to 2000 kilometer. Distance of OB is nothing but 2000 kilometer, right? In right triangle AOB, right? In right triangle AOB, hypotenuse is nothing but AB square is equal to OA square plus OB square. What is OA? OA is nothing but 2100. So 2100 whole square plus 2000 square is equal to, what is 2100 square? It is nothing but 44 lakhs 10,000, right? And 2000 square is something but 40 lakhs. While we adding these two, 84 lakhs 10,000, right? 84 lakhs 10,000. So what we want to find? We got a AB square, but what we are needed? We need the length of AB alone. So taking square root on both sides, then AB is something but 2900 kilometer. AB is equal to 2900 kilometer. Therefore, the distance between two planes after 1 hour is equal to 2900 kilometer. 2900 kilometer, right? Next, sum number 4. In a rectangle ABCD, right? In a rectangle ABCD, E is the midpoint of AB. E is the midpoint of AB. That means AE is equal to EB. Both are equal. And AE by EB is equal to 1. And AE is equal to 2 times of AB, or EB is also, what is it? 2 times of, AB is equal to 2 times of AE, or AB is equal to 2 times of EB. However, we can write whatever we are needed, we can write it, right? If AB is equal to 16 meter, AB is equal to 16 meter, right? So AB is equal to 16 meter, and AD is equal to, right? AD is equal to 6 meter. AD is equal to 6 meter. Then find ED. Then find ED. So how you want to find? See, it is a rectangle. We know that, right? We know that the property of a rectangle is nothing but, what is it? All the four angles of a rectangle is nothing but 90 degree. Angle A is nothing but 90 degree. Angle B is also 90. Angle C is also 90. And angle D is also 90. All the four angles are 90 degree, right? the property of rectangle is nothing but all the angles of rectangle is nothing but 90 degree. So therefore triangle ADE is nothing but right angle triangle. Triangle ADE is nothing but right angle triangle. So with the help of Pythagoras theorem statement, right, with the help of Pythagoras theorem property or statement, we are going to find the D, right? So D is nothing but hypotenuse, right? Opposite to the right angle. The side opposite to the right angle is nothing but hypotenuse. So DE square is equal to AD square plus AE square, right? So we know the value of AD, but we don't know the value of AE. But we can find the AE. See, we know the value of AB. AB is nothing but 16 meter. And E is nothing but midpoint of AB. E is nothing but midpoint of AB. That is, then AE is equal to half of 16 meter, right? So AE is nothing but 8 meter, right? A is nothing but AB by 2, that is 16 by 2, 8 meter, right? Now we know all these two values. With the help of Pythagoras theorem property, we are going to find the DE square. So in right triangle ADE, right, DE square is equal to AD square plus AE square. You know AD is equal to 6 square plus 8 square. 6 square is equal to 36. 8 square is nothing but 64. 64 plus 36, 100. DE square is equal to 100. Taking square root on both sides, then DE is nothing but 10 meter. D is equal to 10 meter. Right. Same like sum number 5. You can take this as a homework. Sum number 5. In the figure, right, in the given figure, right, in the figure, if CD is equal, right, if CD is equal to 17 meter, if CD is equal to 17 meter, BD is nothing but 17 centimeter, 17 centimeter, and BD is nothing but 8 centimeter, BD is nothing but 8 centimeter, and AD is equal to 4 centimeter, AD equal to 4 centimeter. We want to find the value of AC. How we are going to find? See here, we are having two right angle triangle, right? We are having two right angle triangle. One is nothing but BCD is nothing but one right angle triangle. Another one is nothing but ABC is nothing but another right angle triangle. See, we want to find the value of AC alone. So for finding the value of AC, we want to know, we need two values, right? We need what is that? In a right angle triangle, among the three sides, we need two sides, right? We need the measurement of two sides for finding the third side with the help of Pythagoras theorem, right? So we need three sides, but we are having only one side alone. See, AB is nothing but 4 plus 8 is nothing but 12 centimeter. 4 plus 8 is nothing but 12 centimeter. We know AB, but we don't know BC. So without BC, we can't find the AC, right? Without BC, we can't find the AC. So how we are going to find the BC means we are having a clue. What is the clue? In a right angle triangle BCD, right? We know 8 centimeter and 7 centimeter. We know the hypotenuse and we know the base also. With the help of Pythagoras theorem property, we are going to find the BC. If once you are finding the BC and if you know already AB, with the help of these two values, we are going to find the AC. AC is nothing but square root of 369 centimeter. Right? You can take it as a homework. Understood? Easy? Right. Next is sum number 6. Sum number 6. Prove that in an equilateral triangle, 3 times of the square of one of the sides is equal to 4 times of the square of one of its altitudes. See that they said that ABC is nothing but an equilateral triangle, right? Square of any one side of a triangle will be equal to the square of the altitude of the triangle. Square of the altitude of the triangle. We want to prove that given ABC is an equilateral triangle. That is AB equal to BC is equal to CA, right? Equilateral triangle. And we want to prove that I am just taking that side AB and altitude AD. 3AB square is equal to 4AD square. They said that 3 times of the square of one of its side is equal to the 4 times of the square of one of its altitude. 3AB square is equal to 3 times of one side of a triangle is equal to square of one side of a triangle is equal to 4 times of square of altitude. 3AB square equal to 4AD square. We want to prove that. Construction, I'm just drawing that AD perpendicular to BC. AD perpendicular to BC, right? If AD perpendicular to BC, so AD divides, right? AD divides the line segment BC into 2 equal parts, right? See, already we know the property, right? For any triangle, we can draw a median and altitude. What is altitude? Altitude is nothing but we just drawing the perpendicular line, right? Median is nothing but divided into two equal parts, right? Dividing this line into two equal parts, and perpendicular is nothing but altitude is nothing but perpendicular line for the base, right? Perpendicular for the base. But for in an equilateral triangle alone, right? For in an equilateral triangle alone, if you are drawing a altitude, right, then the altitude will be act as a median. Suppose if you are drawing the median, right, if you are drawing the median in an equilateral triangle, then the median will be the altitude. That means in an equilateral triangle, median and altitudes are same only, right? So if you are drawing the median, it will be a altitude, right? It will be perpendicular to the line BC. Suppose if you are drawing the perpendicular line for the BC, then the AD will be the median, right? When the triangle ABC is an equilateral triangle. Only for an equilateral triangle alone, both the altitude and medians are the same line segment, right? So see, if AD is perpendicular to BC, if AD is a perpendicular to BC, so AD divides BC into two equal parts, that is BD is equal to DC. BD is equal to DC. Understood? Why? Because D is a AD is nothing but median. If AD is a median, then D is a midpoint of BC. If D is a midpoint of BC, then BD is equal to DC. BD is equal to DC. Now we are having two right angle triangle, right? Now we are having two right angle triangle. So actually what we want to prove, that we want to prove that 3AB square is equal to 4AD square. 3AB square is equal to 4 times of AD square. Just you can take the in right triangle ADB. I'm just choosing this triangle ADB because we are having AB and AD in this triangle alone, right? Suppose if you are choosing that AC square, 3 times of AC square is equal to 4 times of AD square, you can choose this right angle triangle, right? It's depending upon your assumption, right? Whatever you want to prove, that based on that you can choose a right angle triangle, because we are having so many right angle triangle. Among the right angle triangle, which right angle triangle we are needed, just to choose that alone. By using the Pythagoras theorem property, we are going to prove. So I'm just taking the right angle triangle. In right triangle ABD, in right triangle ADB, right? What is the opposite side? Say hypotenuse AB square. So AB square is equal to AD square plus BD square. AB square is equal to AD square plus BD square. AD square plus BD square, right? So AD is nothing but, right, AD square plus BD square. BD is nothing but, already I said that BD is nothing but, I'm just writing in terms of BC, right? Why I'm just converting in terms of BC means BC is equal to AB, right? BC is equal to AB. Just we can convert this BD in terms of AB, right? So actually what we want to prove, we are needed only AB and AD alone. AB and AD alone. AB, AD is there. Extra what we are there? BD is there. Just I'm going to remove, or I'm just going to convert this BD in terms of AB or AD, right? I'm just going to convert this BD in terms of AB or AD. How I'm just going to convert means, see, BD is nothing but BD is equal to BC divided by 2, half of BC, right? BD is nothing but half of BC. So select BC by 2 the whole square, apply the square, that is nothing but AD square plus BC square divided by 4. BC square divided by 4. Already we know that it's a ABC is an equilateral triangle. Instead of this BC, shall I substitute AB? Instead of this BC, shall I substitute AB? So what is that? AD square plus AB square divided by 4. Just do the cross multiply. So 4 times of AD square, right? Otherwise, you can just keep as it is, no problem. Simplify, then you can take it to the RHS, no problem. What? However, you will get the same solution alone, right? Just taking this AB square by 4 to the LHS, already we are having AB square like terms, right? Taking to the LHS plus AB square by 4 will become minus AB square by 4. So simplify, 4 times of AB square minus AB square divided by 4, right? So 4 AB square minus AB square, 3 AB square. 3 AB square divided by 4. Taking this 4 to the RHS, then 3 AB square is equal to 4 AD square. Hence it is. That only we want to prove. Understood? So by using the Pythagoras theorem alone, we are going to prove, right? So that unwanted variables, right? Unwanted variables, just removing in terms of the same variable, right? Same like that alone, we are going to prove whatever they ask you to prove, right? See, it will be very easy. Actually, the third concept and fourth concept is very easy. Third concept also same like that. We want to find maximum. We want to find the ratios alone. Ratios of the area of this triangle divided by that triangle, right? Area of two triangles, right? So we want to find the area of two triangles. We want to remove the variables. For removing the variable, surely they will give us some clue for removing the variables. Same like that here also, we are not removing, just we are converting into the same variable. What variables are we are needed, right? What we are needed, we are just converting, or we are just changing in terms of the same variable, and simplifying, we'll get the same solutions, right? Example number 7. So number 7, the perpendicular from A on side BC. The perpendicular from A on BC, right? So ABC is nothing but triangle. From the point A, I'm just drawing the perpendicular line on BC. So AD is nothing but perpendicular line, right? BC of a triangle ABC intersects BC at D, such that DB is equal to 3 times of CD. DB is equal to 3 times of CD. Prove that 2AB square is equal to 2AC square plus BC square. 2AB square is equal to 2AC square plus BC square. Right? So see here we are having only that. They didn't give the diagram. Simply just we are drawing the right triangle. Just we are drawing the triangles. From the point A, they ask you to draw the perpendicular line on BC. So AD is nothing but perpendicular to BC, and they have given one more hint, that is nothing but DB is equal to 3 times of CD. Right? So given AD perpendicular to BC, DB is nothing but is equal to 3 times of CD. To prove 2AB square is equal to 2AC square plus BC square. Right? See, we are having two right angle triangles. One is nothing but ADC, right? ADC right angle triangle. Second is nothing but ADB right angle triangle. We are having two right angle triangle. Actually, what we are needed, see, AB square, AC square, BC square. So AB square. So we need this triangle, ABD triangle. At the same time, AC square also there, right? AC square also there. So we need AC also, right? ACD right angle triangle also. We need this both the right angle triangle. We need this both the right angle triangle. So by using the Pythagoras theorem, I'm just going to find. So before that, see here they have given that BC is nothing but, right? BC is equal to BC, right? BC is equal to, see, actually we need the BC also. I'm just going to find BC in terms of CD and DB, right? I'm just going to convert. See, actually what are things we are needed? See the proof. By seeing the proof alone, what are things that we are needed? I'm just converting, right? See here, 2AB square, 2AC square, BC square. So AB square, AC square, BC square. AB square we are needed means, you just take this right angle triangle, we got a AB square. AC square we are needed means, you just take the triangle ACD, right angle triangle ACD, we got the AC square, right? But BC square, we don't have BC square, right? We don't have a right angle triangle, we don't BC. So what I am going to, how I am just getting the side BC means, right? I am just converting this CD in terms of BC, at the same time DB also in terms of BC. Understood? I'm just changing this CD in terms of BC and DB also in terms of BC, because that alone we are needed, right? That's why. So here BC is nothing but BC is equal to CD plus DB. CD plus DB, right? They have given that the given DB is equal to 3 times of CD. So instead of this DB, shall I substitute 3 CD? So CD plus CD, 3 CD, 4 CD, right? Just taking this 4 to the LHS, BC divided by 4. Now I just converted this CD. Now I have converted this CD in terms of BC. BC by 4, right? Next I'm just going to convert this DB in terms of BC. DB, I'm just going to convert this DB in terms of BC. In terms of BC. So from the given DB is equal to 3 times of CD, right? 3 times of CD. So already we have found that CD is nothing but BC by 4. So I substitute here. So it is equal to DB is equal to 3 BC by 4. DB is equal to 3 by 4 BC or 3 BC by 4. So DB is nothing but 3 BC divided by 4. Now we are having CD and DB in terms of BC. Understood? Now I am going to take the two right angle triangle. In right triangle ABD, which is hypotenuse. So AB, right? AB square is equal to AD square plus DB square. Take it as equation number 3. Next I am just taking the right angle triangle ADC. Here AC is nothing but hypotenuse. So AC square is equal to AD square plus DC square. AD square plus DC square. Right? See, just I am just subtracting this equation 3 and 4, because see actually what we are needed, AB square in the LHS, what we are having, AB square and AC square, right? See the proof, what we want to prove, we want 2AB square is equal to 2AC square plus BC square. Just taking this AC square to the LHS, it will become minus 2AC square, right? Minus 2AC square. So we are having AB square and AC square in the LHS. While we are subtracting these two, we will get the LHS, right? So AB square minus AC square, right? Subtracting equation 3 minus 4, AB square minus AC square is equal to RHS, AD square plus DB square minus equation 4, AD square plus DC square. Just multiply minus inside. So AD square plus DB square minus AD square minus DC square. See the like terms, plus AD square minus AD square will get cancelled. So remaining what is that? DB square minus DC square. Already we have find it DB. DB is nothing but 3 by 4 of BC. And DC is nothing but, we have find a DC, CD or DC. BC by 4, right? We have find out that DB and DC in terms of BC. Just substitute 3 by 4 BC the whole square minus BC by 4 the whole square. Apply the square. 3 square is nothing but 9. BC square divided by 4 square 16 minus BC square divided by 16. See that denominators are same, so by 16. So 9 BC square minus BC square is nothing but 8 BC square. Simplify 1 times 2 times. So BC square divided by 2, right? BC square divided by 2. What is an LHS? AB square minus AC square. Take this 2 to the LHS. 2 into AB square minus AC square. 2 into is equal to BC square. Just multiply inside. 2 times of AB square minus 2 times of AC square is equal to BC square. Take this 2 minus 2 AC square to the RHS. 2 AB square is equal to BC square plus 2 AC square. Hence it is. Understood? See, by seeing the proof itself, we have to come to the conclusion how we are going to prove. Right? We are having two right angle triangle. So see that AB square, AC square and BC square, right? So we are having two right angle triangle. One is nothing but AB square and another one is nothing but AC square, right? And see here we are having that BC square, but we don't have BC. So I'm just converting the CD and DB in terms of BC, right? Understood? So while you are seeing the proof, right? While you are seeing the proof, that itself you have to come to the conclusion how we are going to prove. That's very important, right? We'll see one more sum. Sum number 8. In the figure, ABC is a triangle. ABC is a triangle in which angle ABC is more than 90 degree. That is obtuse angle, right? More than 90 degree obtuse angle, and AD perpendicular to CB. AD perpendicular to CB produced. That's very important. Produced means they are extending the line BC, right? And we are getting that AD is perpendicular to BC, right? CB or BC. Prove that AC square is equal to AB square plus BC square plus 2BC dot BD, right? Now we are having two right angle triangles, right? One is the triangle ADB, another one is the triangle ADC. So by using Pythagoras theorem, we are going to prove whatever they ask you to prove. Angle ABC is greater than 90 degree and AD is perpendicular to CB, right? We want to prove that AC square is equal to AB square plus BC square plus 2BC dot BD, right? So see that it's nothing but 2BC dot BD. AB square plus BC square plus 2BC dot BD. How it will be? It's looking like a plus b whole square expansion, right? But the variables are somewhat different, but like the a square plus b square plus 2ab, likewise it is there. Okay, we'll see. We are having two right angle triangle. First we'll find that. In right triangle ABD, right? In right triangle ABD, AB square is equal to AD square plus DB square, AD square plus DB square. Take it as equation number 1. Next, in right triangle ADC, full right triangle, right? In right triangle ADC, AC square is equal to hypotenuse square. AC square is equal to AD square plus DC square, right? AD square plus DC square. This DC is nothing but how we can write this DC? DC is equal to DB plus BC, right? DB plus BC. So DB plus BC the whole square. That is nothing but A plus B the whole square, right? DB plus BC the whole square. So A square plus B square plus 2AB. Just write it. AD square plus DB square plus BC square plus 2DB dot BC. That is 2AB. A square plus B square plus 2AB, right? We know that A plus B whole square is equal to A square plus B square plus 2AB, right? Now already we know that AD square plus DB square from equation 1, AD square plus DB square is equal to, from equation 1, AD square plus DB square equal to AB square. So let's substitute. Instead of this AD square plus DB square, what I am substituting? AB square. So AB square plus BC square plus 2DB dot BC. AC square equal to. Hence it is. Understood? That's a very easy one. Still we are having 3 more sums alone, right? So we are going to complete the chapter, right? Actually this is a very easy chapter, right? Compared to last year 9th standard triangles, this year triangles is very easy, right? Thank you.